In this video, we're going to look at how to find the correlation coefficient in Excel using two different ways. First, we're going to look at how to do it using a scatter plot, and then we're going to look at how to find it using the formulas. So, firstly, the scatter plot. Before you even start, you need to make sure that your independent and your dependent variable are in the right spot. So we want our independent variable on the left side and our dependent variable on the right side. So how do you know what's independent and what's dependent? Well, if something can cause change, a variable can cause the other one to be different, that's your independent variable. For example, age can cause the goals scored in a tournament, in a soccer tournament, to be different, possibly. So that is the independent variable. Whereas it makes absolutely no sense to say goals scored in a tournament could cause somebody's age to be different, which is why this is the dependent variable. So again, our independent variable is the age, which is X, and our dependent variable is the goal scored, which is Y. All right, once you are confident that you have X on the left and Y on the right, highlight both columns, including the headings, click Scatter, marked Scatter, and a graph comes up. Now this graph, not great right now. You would need to change the heading and give it some titles, axes, titles, but that's not what we're worried about right now. We just want the correlation coefficient. So you left click on the dots, right click on the dots, click on Add Trend Line. You want to make sure the type of graph selected is linear, and the option that you definitely need to see is the R-squared value, because that will lead to the correlation coefficient. Because we're going to need it later, let's also display the equation on the chart. And once you're done, press OK. Now you can take this and move it to somewhere more visible, and that is your coefficient of determination. It's actually the square of your correlation coefficient. So we're going to just need to square root that value in order to find the correlation coefficient. So our R-squared value that our graph gives us is 0.05545, and the correlation coefficient is a square root. Now notice that that line, that trend line, is going downwards, which means that the correlation coefficient is negative. So it's a negative square root of that value. So R is, every formula in Excel will start with the equal sign. So I type the equal sign and press SQRT for square root, open my parenthesis, and click on that value. Close my parenthesis and it will square root it for us. Now again, remember, since the trend line is going down, it's actually the negative square root. All right, so that's our correlation coefficient, which is all well and good when you can press insert, scatter, options, type, enter, square root, done. But in order to really see that you understand the process, you're going to have to use some formulas. So we're going to look at how to calculate the correlation coefficient using the formulas. So let's move this over a bit so we can see our formulas. Okay, so now we're ready to do it using our formulas. So the first thing that we need to do in order to use these formulas is to figure out what the average of X is, what the average of Y is, and also we need to know how many numbers we're dealing with. So let's do the count on the numbers first. So of course we could easily count the numbers 1, 2, 3, 4, whatever, or we could look at the end column and see where it starts or whatever, but I want to show you a handy dandy tool that you can always use to count any number of numbers in Excel. As we said before, every formula starts with the equal sign, and we're going to count the numbers, so we type count with one T. Open your parenthesis, highlight the numbers that you'd like to count, just the numbers, close your parenthesis, and press enter. And Excel tells you that there are 33 pairs of numbers here. All right, So we're gonna also need the mean. So we can do the same thing again. We can start with the equal sign and we can type average and do the same thing. However, I just want to show you another handy dandy little tool. So since we're trying to find the average of these numbers, we can click in the box that comes right after those numbers. And there is a summation sign here. And next to it, there is an arrow giving you a few options. We're trying to find the average, so I click on average, and it does it for you. Just press enter. All right, we also need the average of the next column over. So instead of having to type it again or go up there again, we can hover in that box at the right side until we get the back cross, click, and drag. And it gives you the average. All right, so now we have our averages and we have our number of numbers, and we are good to go. However, we're actually going to need these numbers later, very soon. And I don't want to have to look at the very bottom, so I'm going to copy these values and then I'm going to paste them up here. But I only want the values. I don't want the formulas that we typed in. So instead of pressing just regular paste, I'm going to press paste special and I'm going to paste in my values. All right, great. So now we have the averages. We can see them. We know they're 33 numbers, so we can definitely start. All right, looking at this formula, we know that the first thing we have to do is x minus the average of x. So I'm going to actually, so I don't have to type that awkward looking thing into Excel, I'm going to copy it and I'm going to paste it as a heading. It doesn't look amazing, but I can fix it later. All right, so as we said, every formula starts with the equal sign. So equal, I'm going to do the first row, x minus the average of x. Instead of clicking that number though, that can cause a bit of confusion because we're going to be using the same number over and over, and I don't want Excel to be confused about where to locate that number. So I'm just going to type that average in, 27.9697. There's a way to do it. Type some other stuff in to get Excel to know to stay at that number, but I'm just typing the number in. So we did x minus the average of x. Now, in order to have Excel repeat that calculation again, like magic, we can hover at the bottom corner of that cell, click, and drag. And like magic, it does it for you over and over. All right, so according to the formula, the next thing that has to happen is those values have to be squared. Okay, so let's square those values. In our heading, I'll just copy that so I don't have to retype it and paste it in here. Okay, that looks really funny, but let's try that again. There we go, that's better. All right, so every formula starts with the equal sign and we're trying to square this value. So I click on it, I press Shift 6, that's my little caret, to raise it to the second power. So now I'm squaring that value and I press enter. I go back up to that cell, hover in the bottom right corner, click and drag, and it squares all your values for you. Now we can do the same thing for y. So I can highlight that so I have the heading in there and paste it. And we're starting off with the equal sign and we're doing y, which is here, minus the average of y, which I'll type, 4.212121. And now I can fill in the rest by dragging. Now I can square those values and I'll just get my heading in, copy and paste. Now I can square these values in the same way I did before. Equal, click on it, raised to the second power, press enter, and then put it there and drag to fill in the rest. All right, so we're almost done setting up to use all these formulas. Our third formula is the covariance formula. So we're going to have to multiply x minus the average of x times y minus the average of y. So let me just get that heading in so we can do that. And so every formula, as usual, starts with the equal sign. Or first, x minus the average of x is here, so I'm going to click it. To multiply in Excel, you use Shift 8, the asterisk. And we're going to multiply it by y minus the average of y, so that's there. And now we can hover the bottom corner here and do the repeat calculation. And now we have everything in a table that we're going to need in order to use our four formulas. So let's first find the standard deviation of x. We are going to need the sum of x minus the average of x squared. So we need the sum of this column in order to find that standard deviation. So since I need the sum of that column, I'm going to put my cursor in that box. And the easiest way to find sum is just to go up to that summation sign and click sum. Of course, we could have typed the formula as well and pressed enter. Now let's find the standard deviation of x, since we now have that value. Okay, so we know, let's make sure that this is, okay, great. We know that the standard deviation of x is the square root of that value, the sum of x minus the average of x squared, so the square root of that value, 466.969, that's not a point, 0.9697, over the number of values, which is 33. That's when we counted the number of values were 33. So let's go back to that in a second. But let's set up our equation for our standard deviation of y. So we need the sum of those numbers. So I'm just going to put that box there and press my sum sign and press enter. So our standard deviation of y will be the square root of that number, 193.5152, over, and there are 33 y values, so over 33. And or covariance, there is no square root there. There is just a sum of that last column over 33. So we already did the sum formula here. We can actually just drag it over. And so we can now see that the sum of that is negative 70.7879. So negative 70.7879 over, and we know that our n is 33, so that will give us our covariance. So once we figure out those numbers, we can plug into that formula. So let's see what we get. Okay, so after a bit of calculation, we found that the square root of these numbers divided is 3.7167. The square root of these numbers divided is 2.4216. And this divided by this will give you negative 2.1451. And if you type that all into your calculator, so again, we're doing negative 2.1451 over 3.7617 times 2.4216. We type it all into the calculator. Make sure you put your bottom in parentheses to lump those two things together. We should get that, or our value is equal to 0.2356. which in fact is exactly what you got for your correlation coefficient when we did it earlier. Oh, right here, negative 0.23548 or 2355. So we got the same thing and we are done.